Welcome back to my YouTube channel. So today I am going to begin the revision part, and in the revision part this is the first video where I am beginning with the mole concept and the volumetric analysis. Alright, so begin with the mole concept. I have the first thing, that is the average atomic mass. So you know that while you calculate it, if there are many isotopes, then what would be the average mass, or say what would be the mass of that particular nuclei, so we will calculate this by having the mass percentage. All right, so if we have two nuclei, or then we usually take a mass percentage of first nuclei. That for example, for fluorine atoms, you know that 19 fluorine is 99% abundance. This M1 and M2 percentage is actually the natural abundance. This M1 and M2 percentage means natural abundance, natural abundance. If we have a nuclei in fluorine, then we know that there are two nuclei, or say there are two isotopes exist in the nature. The one is the 19F and second one is the 18F. 19F means molecular weight is 19 and 18F means molecular weight is 18. So in this case, how we will be going to determine the average molecular weight of fluorine atom? So we use this formula. By using this formula, we will just put the percentage abundance. How we will put percentage abundance? Like for 19F, we know that it is 99% abundance. And 18F is 1% abundance. So just we need to put 99 plus 1 upon 100. 99. This is the percentage, and we have to put the mass. So 99 multiplied by 19 plus 1 multiplied by 18. Try to understand. M1, that is the mass, and into percentage, that is percentage abundance. So percentage abundance for fluorine is 99% and mass is 99, and for 18F mass is 18 and percentage abundance is 1%, and divided by 100. Upon doing some simple mathematics, you will be able to find out the average atomic mass of the fluorine nuclei. All right. Now one more question for your general knowledge. For you, if you are going to sit for an interview, then there might be a question like this: that how you will calculate the molecular weight experimentally? So very simple answer. You had studied, I think already you had studied in your 11th and 12th, that is the bicolligative properties. You can calculate the molecular weight experimentally. Okay, now moving to the second thing, that is the vapor density. Note my point. Vapor density is actually the relative term. That is the density of one gas with respect to density of second gas or the other gas. Alright, that's why we write it d gas 1 upon d gas 2, and when we put the d in terms of PM upon RT, and finally we reach up to M1 upon M2, and M2 we take hydrogen, and we know that mass of the hydrogen is 2. So simply we know that the formula for the vapor density is M1 by 2, or say mass upon 2, mass of that particular species whose vapor density is have to find out, and the rest in the denominator we have to take the mass of hydrogen, that is the value 2. Why we take this? Because this hydrogen is only a species whose density is minimum. So that is why we usually take this hydrogen. Alright, now the question can be manipulated can be manipulated. And if you are knowing this little thing, what is the little thing? The little thing is the PM upon DRT. Here we are putting D as a PM upon RT, P1 M1 upon RT1, and similarly P1 M2 P2 M2 upon RT2. And if you have been given to pressure or molecular weight and asking and giving some kind of manipulations, I hope you people are understanding what I am trying to say. So in that case you will got a lot of help. Alright, so here you just need to know that their density, this density is actually using PM upon RT. Alright, now moving to the third thing, that is the effective molar weight, or say effective molecular mass. So when we calculate this, we will calculate this, or we will have a need of this when we will having the mixture of the gases. Yes guys, when we will having the mixture of the gases, like in a container there are N2, O2, Cl2 and all kind of gases are present, and then you have to find out the molecular weight or the weight of the whole gases. Then you use this formula and we call it effective molecular weight. Alright, so I had also written it for mixture of gases. So here the formula is Na Ma plus Na Mv and so on upon Na plus Nv and so on. So depending upon the number of species present, we have to write down the number of moles. For say if N2 is present 2 moles, O2 is present 1 mole, then Na will be 2, Nb will be 1, and Ma and Mb are the mass of the N2 or O2. Alright, so in this way you can calculate the effective molar mass. Alright, now moving to the third thing, that is the empirical formula and molecular formula. Empirical formula and molecular formula. So very basic trick that I am going to tell you, that usually the carbon, oxygen and hydrogen are there. So that's why I had taken the example of carbon, oxygen and hydrogen. So what you have to do, you will be given the percentage of those species. Here I am taking carbon, oxygen and hydrogen. So what you have to do, you have to divide the percentage what will be given to you by their molecular weight, by corresponding molecular weight. Likewise, what I had written here, try to see that carbon is actually 38% is given. If for example 38% is given, then we will divide it by molecular weight, that is 12, and oxygen is for say 42 is given, then we divide it by molecular weight, that is upon 16. Similarly hydrogen will be 20% will be given, then we divide by its molecular weight, that is 1. Alright, now when we will calculate this ratio, then we are actually reaching to the empirical formula. When we reached with the empirical formula, one more thing you have to do, that is you have to take the integer values. If you are getting a ratio decimal, then you have to multiply it by any whole number, so that you will get 1, 2, 3 such like values. Then what you have to do, then very basic thing, that you know that in the question you will also given the molecular formula weight. So you know the empirical formula weight because you had elucidated the empirical formula. Since you have elucidated the empirical formula, so you can calculate the empirical formula weight, and in the question you will be given the molecular formula weight. So here you can calculate the N. And upon calculating the N, you have to just multiply it by N to the empirical formula, and you finally end up with the molecular formula. Am I clear or not? I hope I am clear. Now the other thing, that is the concentration terms. Here from here the volumetric part is started. Okay, so what is the concentration? In a very simple definition, we know that the amount of solute dissolved in a per unit amount of solvent. The amount of solute dissolved in per unit of solvent, that actually we refer it concentration. Alright, so now we are classifying it in the two types, that is a type 1 and type 2. So type 1 class is actually something which depends upon the temperature. That means if you are changing the temperature, then those properties will get changed. And the type 2, which actually are the temperature independent, So very basic thing, that from the Gay-Lussac law you had studied that volume directly proportional to temperature. Volume directly proportional to the temperature, that confirming that the expressions which involves volume will depend upon the temperature. So in the left hand side, that is type 1 concentration terms are actually nothing but the volume dependent, or say having the function of the volume. Alright, so the first thing that here is the molarity. So we know the molarity is number of moles upon volume in liter. The second thing is the strength. Strength is actually amount weight upon volume. That is the gram per liter or gram per milliliter. Both way you can write the strength. So weight upon volume, and volume here in liter, that's why the unit is gram per liter. Now the third thing is the normality. So normality is like a thing that grams of equivalent of solute, number of equivalents of solute upon volume. Gram equivalents of solute upon volume. So gram equivalents, you know that number of equivalents is actually number of equivalents which is equals to the number of equivalents. So actually normality equals to number of gram equivalents upon volume. So number of gram equivalents equals to weight upon equivalent weight. So the very basic normality definition is this, and there is a formula that normality equals to molarity into n factor, or so you can write n equals to small n into m. Alright, now the fourth formula, that is the mass upon percentage mass by volume. So it is very clear from definition that the mass of the solute divided by volume of the solution into 100%. Then you can calculate the mass by volume percentage. Alright, so unit depends upon what unit order you are actually taking. Like if you are taking the mass in the gram and volume in the ml, then the percentage MYV will give gram per ml. Alright, so units is totally up to you how you are going, because you have to work according to the question. In the question, what is given to you and how you have to calculate the units, or how you have, it is asking the answer in certain kind of units, then you have to be very careful about this. Alright, now moving to the second type. That is actually the temperature independent. Temperature independent means here the concept of the volume is eliminated. Here we will not discuss about the volume. Here, like for the molarity, you can see that molarity is actually the mass of the solute, moles of the solute upon mass of the solvent. Moles of the solute upon mass of the solvent in kilogram. Alright, so this is the molality. And the second thing that is a mole fraction. Very popular term. Mole fraction is actually for a particular species we define, like there are N2 O2 are present, then we will have a mole fraction for N2. We will be having the mole fraction for N2, and that is the number of moles for N2, number of moles upon of N2 upon total number of moles, like total number of moles, that means moles of N2 plus mole of O2. If in a container two species like N2 and O2 are present, for in a container two species N2 and O2 are present, then the moles of N2 plus moles of O2 will be the total moles, and for a mole fraction is defined for a one particular N2 for N2 or O2. So moles fraction for N2 will be moles of N2 upon total moles. Alright, similarly for mole fraction also is actually XA plus XB equals to 1, XA plus XB equals to 1. So you can calculate easily the mole fraction of oxygen or O2 very easily. Alright. Okay. Now the third thing, that in the right side column is the percentage weight by weight. Percentage weight by weight, percentage mass by mass, that is the mass of solute upon mass of solution. One very basic thing that I want to highlight here, that in molality we take mass of solvent. We take mass of solvent in the denominator. Otherwise, in all of the concentration terms, we take the mass of solution. So this is very thing that we usually forget during when we are doing the calculation in the exam time. Alright, so this thing you need to be very careful. Now the percentage mass by mass we had done this way, and now we have ppm, that parts per million. This is a very useful quantity when we have a very little amount of solute in the solution. Very little amount of the solute in the solution, then we use this ppm value. So ppm is actually in the 10 raised to the power 6, the mass of the solute upon mass of solution into 10 raised to the power 6. Okay. Now the important thing that now come into role is that if we have to go in the question, if there are such like questions like molarity is given and mole fraction is being asked. Molarity is given, molarity is given and mole fraction is being asked. So how you will be deal with such kind of questions, because there is no direct correlation among them. So how you will calculate? Let me tell you, you can calculate by using density. You will be also given the density in the question. So by using the density concept, you can actually move from type 1 to type 2 very easily. For example, if normality is given to you and question is asked about the percentage mass by mass, then by having the density in with you, you can actually solve the question for in terms of using by density. You can calculate the mass by mass by using normality. Alright. Now so this is actually for this we will use box rule. For interconversion purposes we will use box rule. So let me tell you what is the box rule. So here what I have written here, that for interconversion of type 1 to type 2 concentration terms, that means if concentration terms given to us are different, it means one from type 1 and other from type 2, then what we will do, have to do these two things. We will have to do these two things, that whatever given to us, for example, you will be given molarity is given to you, so you know that is the moles by volume. So you have to put the denominator equals to 1. That means you have to assume the volume NYV, because molarity is equals to moles upon volume. So volume you have to put equals to 1 liter. You have to put the volume equals to 1 liter, and then you can calculate the N, that is the numerator. You can, because molarity is given, and you can calculate it because you have taken the volume 1 liter. So you are now having moles and volume of both of the solution. Alright. With the moles you can actually find out the weight, because moles equals to weight upon molecular weight. So by using, if you have calculated moles, then you can find out the weight. Alright, so now you have to fill, you have to fill the box which is being shown in your screen. Alright, you have to fill this box. How you will fill this box? Let me tell you. First let me tell you how you will make the box in the exam time. Just make a very simple 3 row and 3 column box, and in the rows you have to take weight, volume and density. In the rows you have to take weight in the first row, volume in the second row, density in the third row, and in the column you have to take solute, the first column, the second column solvent, in the third column that is solution. So I recommend you to please write it in your notes and practice at least once or twice. It will be very, very useful for you to determine any of the properties concentration terms if it is given in a very rotated way or in a very tricky way. You can easily reach up to the answer. All right. So now you have to do, you had the weight and the volume, all the things you have. Moles, that is the for solute. So moles of solute, then you can find out the weight of solute. Now you have the weight of solute and you have the volume of the solution. All right. And also one more thing, that you will be having the density. You will be having the density, that is the other term. And now with these data you can find out any of the thing. You can find out any of the thing whatever been asked in your question. It is very, very useful technique, and I recommend you to solve 2 or 3 questions regarding with this particular subject. That means interconversion of type 1 to type 2 concentration terms, and then you will definitely praise this thing. All right. Okay, now one more thing, these formulas will be very, very helpful during the calculation. So number of moles, that is actually nothing but the number of atoms or the molecules or the ions upon Avogadro number. Alright, so this is actually the number of moles. So it is actually the whether it's atoms or whether it will be ions or whether it be molecules. So you have to take those atoms and then number of atoms. Like for a 1 mole, in a 1 mole, how you will be having number of atoms? Because if you put n equals to 1, number of moles equals to 1, then the number of atoms would be Na, that is the Avogadro, that is the 6.023 into 10 raised to the power 23. All right. Okay. And one more thing, in terms of liter or in the volume, you will be having the number of moles as volume of gas at STP, standard temperature and pressure, and upon 22.4 liter. Note here I had taken the pressure as 1 atm, but in the standard temperature and pressure now we had decided to take 1 bar pressure. But don't worry about it, you can use this formula and you will not get stuck anywhere. Alright, because all of in our calculations, whatever will be given to us, in all the situations, this particular concept will be easily employed. Alright, now we have now the volumetric processes, some processes. So first we know dilution. First let's see the dilution. Dilution means take it as an example. In a bucket you have a 2 molar solution. There's a 2 molar solution. Now you have added 2 liter water over it. Now you had added 2 liter water over it. So what you did? You had diluted the solution. And this overall process, we call it dilution. We call it overall process as a dilution. So in the dilution, you know very, very, very clear that moles cannot change. Why? But volume can change. Definitely volume is changing. But in the definition of the molarity, as I had said, that 2 molar solution it is. So with the definition of the molarity, it is the number of moles upon volume. So volume changes, but moles didn't changes. So how you will be going to use the formula? So the formula could be m1 into v1 equal to m2 into v2. That is nothing but you are actually equalizing the number of moles. Number of moles before the dilution equals to number of moles after the dilution. So everywhere you have to use this one. You have to just point out that whether this process is a dilution or not, whether this process is a dilution or not, and just try to fit in your mind that in the dilution moles does not changes. All right. Now the second thing, that is the sampling. In the sampling means if you have a 100-liter tank where you had prepared a solution and you are just serving it in 10 small buckets, that is the sampling. You are making the samples of that particular stock solution. In the tank you have the stock solution and you are distributing in the buckets. So you are actually, what you are doing, you are sampling it. So in the sampling, if you had prepared any of the solution for a fixed molarity, like a 2 molar solution, then it will not changes, and whether you are using it 100 ml or using the 100 liter, the molarity is fixed because it is defined for the unit volume. So molarity does not changes. So in such cases you can take the molarity before the sampling and after the sampling as equal. You can take the molarity before of the sampling and after of the sampling as equal, and molarity as it's by definition it is moles upon volume. So you can derive to these two equations and you can use it. Alright, now the third thing, that is the titration. You know that gram equivalence is actually equal. When we titrate it, we take the gram equivalence equal. So N1 V1 will give you the gram equivalence or number of gram equivalents. N2 V2 also give you now gram equivalents. So gram equivalence of acid equals to gram equivalence of base. That is actually the definition of the titration. Now we have the mixing. Mixing means we are adding the acid to a base or base to a acid. Then what will be the resultant normality? So try to understand, if we are adding acid to the acid or base to the base. Try to listen carefully. Adding acid into a acid or base into a base, then you have to use the left hand side formula for the resultant normality. That is the N1 V1 plus N2 V2 upon V1 plus V2. So N1 V1 is the before of the solution, the first solution whom you are adding the second acid for a base, whatever you are adding acid into acid or base into a base, then these are the corresponding normalities and the volume, and divided by the total volume. So that will be the resultant normality. While in the case if you are adding acid into the base, then the concept will be slightly different because of the reaction between the acid and bases. Neutralization reaction will occur. So you will have a different formula. You will be having formula like N1 V1 minus N2 V2 upon V1 plus V2, and this would be the formula that you will be using when you have an acid and base. And if you have to tell whether your resultant solution will be acidic or resultant solution would be basic, so in that situation how you will go, you have to see that which have a higher magnitude. Like for N1 V1 has a higher magnitude or N2 V2 has a higher magnitude. So if N1 V1 is higher, then if it is denoting for the acid, then resultant solution will be acidic. Alright, and if N2 V2 is higher, then if it is representing the base N2 V2, then the resultant solution will be basic. Alright, now moving ahead, we have two more things and then I will end up this video. So ionic strength, that is the for ion, what is the strength in the solution. So we use formula I equals to half summation of Ci Zi square. It is Ci Zi square. So Z is the charge, Z is the charge on the ion, and the C, that is the concentration of the ion. Okay, so if there are 5 ions are present, then you have to take each concentration of each and every ion, and you have to multiply it by square by its charge. Like for calcium, you have to take the 2 charge and 2 whole square, and likewise you can solve the questions. Okay, now the last thing, that mean ionic activity coefficient. Mean ionic activity coefficient. So the derivation is actually, or say the formula is log gamma plus minus. Gamma plus minus is actually denoting the mean ionic activity coefficients. So it is the formula minus A, and for water this value is 0.509. So minus A, Z plus and Z minus. For example, there is a HCl, so Z plus, that is 1, and Z minus is 1, and root I is actually the ionic strength. So first of all, in order to calculate mean ionic activity coefficient, you have to calculate the ionic strength. You have to calculate the ionic strength, then you can move on to the mean ionic activity coefficient. Okay, and for just calculating mean ionic coefficient by formula what is given to you, so for AX/BY molecule, the mean ionic coefficient would be this, what is being shown to you. Okay, so I hope you people has enjoyed a lot this video, and will give you quick revision. I hope that your ambitions are getting satisfied. Okay, so I am just signing off right now, and we'll meet in the next video with having a revision over the another topics, another chapters. So see you, have a good day, bye bye.